Thanks, Felicia. So great to be here. And well, I've given a lot of presentations, but this is awesome. Yeah, I just want to hang and look at it. It's really cool. Visualization is such a key part of the whole game because we're so visually oriented animals. I mean, we really are pattern recognition systems. We make decisions based on what we see. We interact with a three-dimensional world, a four-dimension if you include time. And so not by accident that I'm here today. I mean, we're building a new AI that inhabits virtual digital spaces and helps us manage our cities, airports, ultimately our climate, our planet, everything. And it's really exciting to be here because I think it's going to lead to a lot of collaboration in the next few years between us all. So the company's called Versus, like metaverses. Certainly it's like a digital twin. We work a lot with digital twins and metaverses. We are an AI company. But not the AI that you're used to or have heard about. And we'll talk a little bit about that today. But we also have a foundation called the Spatial Web Foundation. And the Spatial Web Foundation is creating a new set of protocols, kind of like the World Wide Web protocols. And what they do is they create, instead of a 2D World Wide Web of pages, they create a 3D World Wide Web of spaces. And so, again, exactly what you guys are doing with digital twins, but now we've got a protocol so that we're not just silo building something and then using it like a game. We actually can create a web of them, so we can interlink them, move between them easily, share data between them. And we have a new modeling language called the hyperspace modeling language, which is kind of like a scene graph language. And so it gives the AIs and the digital twins a way of communicating with each other, updating each other, and really we get something similar to what we have now. I think we started with maybe 10 web pages back in '93. I think we're at 10 billion web pages today. So when you create a decentralized open protocol, you really get this exponential growth of the system. And so nobody's telling everybody what to build. You don't have to ask anybody if you want to build a website. You can build it and load it up. And so we want to do that same thing now for three-dimensional environments. And so the other thing that's kind of unique about us is everybody's hearing about ChatGPT, things like Stable Diffusion, other new large language model type programs that are called AI, artificial intelligence. But I think what you'll see today is they have certain limitations that will keep them from taking us where we really want to go, which is to artificial general intelligence. And what we've discovered is the pathway to an AGI. And that's really what I'm going to walk you through today. But at the end of the day, if you look at like what OpenAI is doing and Google's doing and even Microsoft now with Bing incorporating OpenAI and Stable Diffusion, they're building a large machine. And they load it with billions of parameters. And then you get to interact with that large machine and ask it questions or ask it to do tasks, and it will make you a beautiful image. It will write you a beautiful paper, even a scientifically cited paper. But it's a giant machine built by a company. ChatGPT 2, they think it probably cost $300 million to build. But then they had to start working on GPT 3. There's another $300 million to build. Then they had to start working on GPT-4, another $300 million to build. And then you have to run that giant machine. And so that isn't how the World Wide Web works. That isn't even how the internet works. The internet began 50 years ago, and somebody said, how could we make a network of computers with no central computer, no central authority who I'd have to call to join? Before that, if I wanted to join an IBM network, I had to call IBM, pay them thousands of dollars, buy a piece of special equipment from them, and then I could join the Sabre network. But if the central computer went down, all the terminals went down. So how do we rebuild a resilient network? And so the idea was maybe we do something like the electrical grid we'll have a standard not owned by a company. And then we'll give every machine an address, and we'll let them send little text files back and forth to each other. And so that's TCP/IP for you, all of you that are in tech. And we give every machine an IP address, and then they can send little files back and forth. That became email. That was a killer app. For 25 years, that was pretty much what we used the internet for. But we went from 4 computers in 1970 to 40 million computers in 1995. And now we're at 40 billion computers plugged into the global internet today. We got about 150 billion IoT devices plugged in today. They expect us to have more than 1 trillion IoT devices online in probably the next 10 years. So, largest engineering project humanity's ever undertaken. It's the internet. So Tim Berners-Lee came along in the early 90s and said, well, this network's already here. Can we do something more with it? We're sending email, but the speed of the network has increased and the speed of the ships has increased. Maybe we could start sending scientific documents around to each other. That would increase the research capabilities of humanity. And maybe if we could make something called a page, a web page, then we could have a network of pages. Well, let's just do the same thing we did with the internet. We'll give every page an address. And then we'll give them an open protocol not owned by a company. And that became HTTP and URLs. And now, again, 10 web pages. We're at 10 billion web pages today. So this is really a fundamental thing. So now we have the physical layer of all these 40 billion machines and fiber optic cables and satellites and data flowing at light speed globally. And now we've got this beautiful library of pages. So can we do something more with this network? Oh, another protocol. Oh, let's create a protocol then for spaces. So we call it the hyperspatial transaction protocol because it helps us transact in and between spaces. And then we have a hyperspace modeling language, which is different than a markup language. Markup language is a standard language, so if we mark up a web page, a browser can read all the web pages. We all agree to that standard. Well, now we have a modeling language, so one set of iPhones or even a smartphone or a laptop can see with a spatial browser, can see any space now. And so you can navigate between spaces if you agree on the standard modeling language. So that's an IEEE standard. It's now in its 3rd year of development. It's coming on stream probably first of about 6 months from now. And you can go to the IEEE standard and look up the Spatial Web Protocol. It's a P2874. So that gives us a new foundation layer for visualization. And then you're already working in digital twins. You know what they are, metaverses, 3D spaces. Now we've got an AI then that can inhabit those digital twins. And so we don't want to build another big box. We want to replicate what the internet's already doing and what the World Wide Web's already doing. Well, that means we have to give you the tools. And then you build an AI. You build an AI. This person's a nutritionist. They build an AI on nutrition. This person's an educator. They build an AI for education. And so, but they have a common protocol now, so they can all talk to each other. So now they're co-evolving. They're all learning from each other. And so you get a distributed, decentralized artificial intelligence network. And then the collective intelligence of that network is what creates the AGI. No single company creates it. It's the collective wisdom of the whole thing as it works together. Just a really simple example might be you might do a highly accurate digital twin of Linköping. And so you've got an accurate digital twin of Linköping. But somebody else has done a digital twin of all of Sweden. But they don't have the accurate digital twin of your city. But because you're on an open protocol, when I'm navigating through the digital twin of Sweden, when I come to this city, I can suddenly access the accurate digital twin that was created by a separate group that's located within the confines of the map of Sweden. And the Sweden map might be part of a larger thing that the EU is doing of a whole digital twin of all of Europe. And of course, what we're going to see probably, I think, by 2030, 2035, we'll probably see an accurate digital twin of the entire planet. So ultimately, probably in 2035, maybe earlier, any child will be able to float a holographic globe in front of them, and accurate with weather and everything perfect, and be able to zoom in and out right down to a single tree or all the way out, and then run forward and backwards simulations from the past and into possible futures. And that'll help us manage our climate and supply chains and other kinds of issues we're facing as our collective humanity right now as we move forward. So that's why we say we make AI tools, you all make the AI. That's what Tim Berners-Lee did. He said, here's HTTP and HTML, here's a browser, rock and roll. And then Jeff Bezos made Amazon, Google boys made Google, and on, right? Facebook and all the rest of them. And so what we want to do is unleash the collective intelligence of humanity in partnership with AI and digital twins. Now that can operate at a company level because companies have problems they're facing. But then it can operate at a community level, smart cities. It can operate at a state level for the whole country, and clearly regions. So one of the first applications we did was in partnership with the European Union. They're very concerned about drones. There's going to be a lot of drones in the sky in the next 10 years. With airplanes, we can talk to the pilots. Hey, change your heading by 30 degrees. Slow down, we want you to land 5 minutes later, whatever it is. With drones, we're going to have DHL drones, we're going to have Amazon drones, we're going to have police drones, we're going to have photography drones in the sky. They're going to run into each other, they're going to land on people and crash. They're going to cause all kinds of problems, kill people, cause fires, all kinds of things. There might even be terrorist drones. They're using drones in Ukraine and Syria, places like that. So the European Union was really concerned, how do we manage drone traffic? How are we going to do this? Anybody have any ideas? They put out a call for papers back in 2019, end of 2018, 2019. We're a U.S. company. We're based in California, but we have a European headquarters in Eindhoven in Holland, and at the high-tech campus there. And so 85 companies put in proposals, Siemens, everybody, and we won because there's really only one way to do it. Turn all of Europe into a giant computer game, a big hologram, and then let the AI manage the traffic and through smart contracts and other kinds of things, create drone highways, drones flying east and west, go at this altitude, west to east the other, don't fly near an airport, exclusion zones, all kinds of things. So local governments then can write the laws the way they want drone traffic to work, and then the drones follow those laws. So one of the big projects we have is in partnership with Maastricht University on reading a law and converting it into computer programs that can control drones. So that way, if you change the law, then the drones know the latest law. So Dentons is the largest law firm in the world. And if you go to our website at versus.ai, you'll see a new white paper that we've done in partnership with Dentons on how do we manage drones, AIs, everything through actual writing of our laws. So that way we have governance. It's one of the biggest issues that EU is concerned about right now with AI. How do we govern AI? And so we've actually got a solution for that as well. Anyway, so we beat out 85 companies, and they were all pretty major companies, and everybody, well, who is this Versus company? And it just shows you this is the way these things work. New technologies develop and come out and replace other things. So we're in the era of AI, the big name has been OpenAI, generative AI. We're doing a different kind of AI. It's called active inference. One is kind of more for creating content. What we're more interested in is operations. How do we operate in real time? How do we manage things? How do we address things? A lot of the great research that led to OpenAI's breakthroughs came out of University College London. UCL is a big neuroscience center in England, and a group of researchers back in 2010 left UCL and set up a company called DeepMind. And they were going to offer AI services to corporations and governments on this new kind of deep learning AI. Google came in 2012 and said, why don't we make you guys part of Google? We'll give you $500 million and join us. and that became Google DeepMind. So they've been pretty much the leading AI company in the world for the last decade. And a lot of the work at OpenAI is a spin-off from all the deep learning work, neural network. So on the left-hand side, you've got neural nets. Long history of them, 30 years or so now of neural nets, deep learning for the last 10, 15 years, and large language models since 2017 for the last 5 years. And so that's been a path forward. But it won't get us where we really want to go. It's still a machine. And machines are physical, static objects. You build ChatGPT-2. It's a machine. You can use it. But then you have to build a new machine called ChatGPT-3. And then you have to build a new machine called ChatGPT-4. Well, that isn't the way humans work. We evolve. We evolve our consciousness. So we're very interested in pulling together a team based on a new kind of AI called active inference, which is an evolving AI. First one in history. So this is a momentous moment because really since the dawn of the printing press until OpenAI, we've really been in the machine age. But now we're entering a new age. It's almost synthetic biology. This is a biological model of intelligence. The lead PhD there is Dr. Carl Friston at UCL. He's the #1 cited neuroscientist in the world. His, good academic, maybe has 10, 20, 30,000 academic citations. Dr. Friston has 280,000. And most of these people are people who did their PhD under Friston. It was theoretical work for the last 8 or 10 years, didn't have a commercial application. My company was building a new nervous system based on these protocols to link all the IoT devices on the planet together and all the metaverses and digital twins. And we met Dr. Friston's team, and we hired the guy just to the right of Dr. Friston there, Dr. Maxwell Ramstead. He became head of R&D at Versus. And then we slowly developed active inference and integrated with Versus technologies and integrated with the spatial web technologies. And then Dr. Friston then joined us as chief scientist. So pretty much that group would be, if the old group was DeepMind, this group would be Nested Minds, and that's the AI department for Versus. So really great academic credentials and a great team. We're about 100 people in the company, so we're still very small, but as you guys know in research, that's still a pretty large team. Raised about $50 million. We're a public company already, so growing pretty fast. That's Carl, and it's really called true AI because, in a way, ChatGPT and the other machine intelligences are machines. So technically, they're not really intelligent, but they mimic intelligence. So they're good enough that it feels intelligent to us. But what we really want is true intelligence. And that's really what we're working on. And that's what's so exciting about this for all of us. Put out a white paper. It's available online for you guys to read. If you go to our website, it's there. It's called Designing Ecosystems of Intelligence. So again, we're not going to build this machine. You're going to build it. All of us, all over the world, just like we did with the World Wide Web. Millions of people built the World Wide Web. Wasn't one company. There was one company that tried to build the World Wide Web before. It was called AOL.com. And I don't know how it was over here in Europe, but in America, your mailbox was full of CD-ROMs every month of AOL.com. And you could go on AOL.com and you could read the New York Times, the Wall Street Journal. You could check the stock prices. You could email. You could text. And then when the web kicked into gear, AOL.com failed and went away because decentralization is much more powerful and unleashes much more intelligence than having a single company try to do it all. And so we're just, again, following the original web design here of decentralizing the building process. This is the white paper for OpenAI. Which is an LLM. As you can see, its primary focus really has been on natural language processing and computer vision. And that's why most of what we have right now are OpenAI is producing content in the form of documents or spatial diffusion, and others are creating beautiful images and things, and they're really valuable. But what you'll see as the true AI comes on board is it becomes more like a general contractor, so it can still deploy these existing neural net technologies. They've been developed to read MRI scans, looking for cancer and other kinds of things. They're great. Nothing wrong with them. They're just called narrow intelligence. So if you have an artificial general intelligence, it can deploy those as needed. And so it's not one versus the other, but one is really kind of sitting above the other one. And the applications for AI are infinite, right? I mean, they're going to touch every part of our lives. Healthcare, of course, huge. Defense, running our cities, homes, everything. We're all going to have a personal digital assistant, something like Jarvis. Probably everybody here saw Iron Man. If you haven't, it's worth seeing just to see Jarvis. But Tony Stark has a personal assistant that helps him design his Iron Man suit and do a lot of other things. What they got right on Jarvis was the intelligence of the AI that's working with him. What they got wrong was only Tony had Jarvis. Oh, Jarvis is software. Well, then I would just tell Jarvis, make 8 billion copies of yourself and give everybody Jarvis. And that's what's going to come. So we're releasing a baby Jarvis probably in July, August, September, somewhere in here. And then it'll just grow with you over time. And it'll be, if you think your dog loves you, I mean, your Jarvis loves you even more. It'll help with your finances, your health, all kinds of things. It's going to be remarkable. And so when you get an intelligent AI that's evolving and learning and growing, and not only from its interactions with you, but with all the other Jarvises that are all over the internet, all learning from each other, because if this Jarvis learns something, like when you improve the digital twin of Lynn Chipping, then if I've got the meta model of Sweden, then automatically anybody accessing that meta model has a better version of Lynn Chipping. So anything any AI learns, they all learn together. So that's why you get this collective intelligence rising, and that's how you get to an AGI. But you can see, the other thing you can see on here is a lot of this is not related to creating content. It's automating process. Well, you can't automate process with an LLM because an LLM is probably somewhere between 70 and 90% accurate. Well, you can't run your airport on that level of accuracy. You've got to have a more accurate system. And how do you get a more accurate system? Well, you're looking at the world in real time. So neural nets are trained on training data, and so they're only as good as the training data, and they're only good to the point where they were trained. And so what happens when I interact with a neural net, I go, tell me the story of Sweden. Tell me the story of history of Sweden. And it'll write me a beautiful article. But it does it by looking inside at its 900 billion words or parameters. Well, what's that got to do with what's going on in the airport right this second, right? So you've got to have eyes. And that's where the IoT devices and the networking and the internet all come together. So by having a protocol that links all the IoT devices together, the AI has access, can see the world in real time. And that's why we won the European drone project. Because this AI is looking at the world in real time. It can call up an LLM when it needs it for something, but it's actually seeing things and making adjustments to its mental model of what's going on in the world in real time. And therefore, it can make more accurate predictions or decisions or suggestions. So you can see there's no other way. Once you see it, then there's no other way to do it. You still use LLMs for entertainment and other kinds of things, but if you're dealing with anything that's mission critical, from medical to air traffic, to even city traffic, to the electrical grid, anything that real-time data is critical, LLMs are they're not going to get you there. So too many errors. That's one of the biggest problems with the current neural nets. It's just, and you don't know what they are. Sometimes people will write a bio for me when they're introducing me for a talk, and you can tell when they've used a chat GPT to write the bio, because it'll say things like, oh, I'm a scientist at Microsoft and other kinds of things. We work a lot. Microsoft's one of our partners, even on the drone project. They handle the Azure, handles our data. But, and so I do a lot of work with Microsoft, but I don't actually work for Microsoft. I've never worked for Microsoft, but it'll write that, because that's how it puts its words together. They're all mathematically calculated. Another thing is alignment. There's how do we get these AIs? The European Union is really fearful about these AIs coming in and kind of ruining our society a bit, because they don't really have our values. They don't really have our understandings, and again, they're inaccurate a lot of the time. And so when you flip it over and you have you building an AI, your knowledge of nutrition, your knowledge of education, your knowledge of finance or whatever, then you're aligning it just the way you do with a website. And so if I'm building a big neural net, I've got to clean all that data. I've got to go through it and look for problems with terrorism and other kinds of things in there, racism, other issues. I don't have to worry about that so much if you're building the AI, because if you put up a terrorist website, everybody sees it pretty quickly and you're taken down. We've got an immune system there. But we don't have an immune system inside a big neural net for this reason. It's called the black box. The way neural nets work is you've got layers of neurons. That's why they're called deep learning. And so when it arrives at a decision, whether it's a chess move or whether it's a medical a recommendation, you don't really understand how it arrived at that. So imagine you're a doctor or a surgeon and you've got your AI assistant and it's going like, well, looking at the situation, we recommend you amputate the leg. How'd you arrive at that? Hard to get the explainability. But if you have an ecosystem of AIs that are all talking to each other, and you can actually trace the line of decision making, now you've got auditability, explainability, and solve a lot of the problems that the EU is concerned about. The other problem, of course, is that the access to data is very limited for a neural net. They can only scrape public data, but 95% of the data on the web that they're trying to scrape is behind some kind of a login, paywall, firewall, whatever. And since we're not building the AI, you can have your own internal AI for your company, and you can expose as much as you want or as little as you want to your partners as it relates to the business you're doing globally. And so again, we're not building it, you are. So all that data that's available in the world is suddenly available to AIs and able to be used by a company, government, or different organizations. So in general, then we've kind of got this kind of a quick summary. We've got a narrow AI on the left, which is things like OpenAI and other neural nets and LLMs. And on the right, you've got this new approach to a general AI. So one is called machine learning, the other is active inference. One has got a top-down model, a big company builds it. The other is a bottom-up model, you all build it slowly, just like the World Wide Web. One's a black box, the other is explainable. One's monolithic, it's a giant thing. The other is interoperable and modular. If something crashes on the other one, just like the web, if one website goes down, nobody even notices unless you're going to that website. The web continues to operate fine. The other one's kind of static. You got to wait for 2 years while they build the next machine. The one on the right is evolving every day, every moment, actually. One's very expensive to build. Costs OpenAI, $200-300 million to build it. That's why they had to raise $10 billion. We raised $50 million, and that's just to build the tools to let you guys build it. So we don't actually have any cost in building it because it's crowdsourced. You're building it. Tim Berners-Lee, it doesn't cost him anything to build the whole World Wide Web. He just released HTML and HTTP and said, go. And other people build everything else. We've done one more step than he did, is we built the equivalent of WordPress or Shopify or other tools to help you build AIs. But essentially, there isn't this big expensive front end of building and cleaning and all this kind of stuff. It's all crowdsourced. One's a higher error rate. Others, you never get to zero error rates because even models are approximations, but your error rate is now under your control and you can measure it. And on the left, you don't really have a world model. When I ask an LLM, tell me the history of Sweden, it has no idea what Sweden is. Doesn't even know what history is. It just takes those words and runs mathematical calculations and goes, oh, history, Sweden, oh, these words go with it, and they start to build it almost like autocomplete does on your email. When you're writing it, it'll suggest. And that's really what it's doing. It's really an autocomplete on the left, suggesting the next token, the next word, the next word, the next word. On the right, you actually have an internal world model. Well, if you got a digital twin, that's a world model right there. You're starting with an accurate world model. But now, instead of just being a static digital twin, it's actually got sensors in the digital twin. So now the digital twin is being updated moment by moment. When I move this glass, the digital twin of this room is just changed. You know, if I do something even more radical, it's a big change, and it may affect even egress if there's a fire or something. And something gets blocked, well, then we're going to take everybody out that door instead of that door. And so if you have an internal world model, now you can actually update that world model. And that's kind of what we're doing as human beings. We're learning every day a little bit more. I've been to Sweden many times, but if I hadn't come to Sweden, it would expand my world model to come to Sweden because it's very different than California. I would know about your city, or I would know about Stockholm or the archipelago or whatever. And so I'm constantly learning every day. But you've got to have an internal world model to modify. And so if your world model is the digital twin of your entire city, well, obviously you can handle things like traffic and energy and things in a much more accurate way than you could any other way. So basically, you got two architectures. One is an expensive monolithic machine from a huge corporation, and the other is a web of networked evolving digital organisms from millions of individuals. And clearly, that's the ecosystem model, which is what nature's pretty much done. And so this is kind of what's also technically called biomimicry. So just another, the one on the right is basically data in, data out. The one on the left here, and the one on the right is a cybernetic cycle. It's constantly evolving. It's learning, it's acting, it's watching, it's updating. So this is a cybernetic loop, and it's endless. And so if it has a level of intelligence of 100 today, it will have a level of intelligence of 200 in a year, and then 400, 800, and so on. And that's how you get to an AGI. And so to get away from the word AI, because we think it's kind of been ruined, we call the AIs that you're building individually intelligent agents, IAs. So it's the AIs all talking together, make an AGI. And so, this is something we've been dreaming of for a long time. So in all of our science fiction, and it's about to happen. The spatial web, a hyper-integrated, hyper-personalized, and interoperable network of humans, machines, and intelligent agents. Could be our greatest invention yet. This is something we've been dreaming of for a long time, and code's cracked the code, and it's coming. I think we'll release the tools to all of you, and probably in January. The final 6 months of we've been testing for the last 3 years here in Europe and the U.S. We should have the tools available for you guys to start building things about beginning of the top of the year. So how do you make an IA? So we use knowledge graphs. We take raw data, put them, and we've got an automated system that creates knowledge graphs from raw data. And so AIs do a lot of the heavy lifting. So probably by 2025, 26, 27, it's probably pretty much no code time. Probably talk it into life. So the agents. Cloud or at the edge, you've got total flexibility. They can see the world. They can interact with the world through drones and robots and make actions. They can read things like temperature and light and other kinds of BIM models and events and other kinds of data coming in. So it's a cycle: sense, learn, plan, act, sense, learn, plan, act. It keeps looping around. Again, the big three. Sense the environment, build the mental model, act on it, and then keep that loop going. And pretty much we've got data normalization tools because large corporations, in particular in government agencies, they might have data from 100, 200, 300, 400 different sources. And a lot of times the data is siloed, and we're throwing things into data lakes and hoping for the best. But we've got data normalization tools that convert that data into these knowledge graphs. And so we can kind of read pretty much any kind of data. So kind of here, then we've kind of got a replication of a digital human. So you've got the AI being the active inference, builds the world model. It's got sensors that can read the world and update the world model. It's got robotics, so it can interact with the world and move things around. It's got NLP, so it can communicate with humans. It's got its own language, actually, HSML, just like HTML. HSML is a language the AIs can all speak to each other. And then the spatial web provides the kind of the nervous system to connect it all together. So kind of radical, crazy, fun science fiction stuff. It's been an absolute pleasure working on it. So at the end, you get these intelligent agents, and you can build them for anything and any kind of use, and they'll do very specific things in a factory. They can do very more general things. They can provide services to citizens in the city. They can provide post-operative medical support, digital augmented reality nurses visiting your house and guiding you through taking your medicines or doing your post-operative exercises. I mean, all kinds of science fiction stuff that we see in Blade Runner and Minority Report and everything else. But now it's actually working in the lab, really cool. So you get a spatial web of these IAs, we call them cosms, and that creates an ecosystem. It's a knowledge sharing network, and it's a marketplace. I mean, just like apps, the App Store, Apple built the first 10 apps when they launched the iPhone because they built the iPhone. So they kind of show, here's an app. This is what an app is. But you can make them. And so they opened the App Store. And now there's, 2 to 3 million apps in Apple's App Store and 5 in Google's App Store. So same thing's going to happen here. The difference is the apps in the App Store don't talk to each other. They're unaware of each other. The apps in the ecosystem are all like websites. They all talk to each other and can be indexed. There's the stack. Very similar to the World Wide Web, layer 1, layer 2, layer 3. Layer 1 is your spatial protocols, HTTP and HSML. Layer 2 is the COSM toolkits that help you build your applications. And then the apps are where they, just like the websites would be in the, or the apps would be in the current models. So we provide the lower 2 levels, and then anybody just builds anything they want on the top level. So we kind of took the best of the App Store idea and the best of the web idea and kind of merged them. And then you get this network. So this is where the magic happens. The agents, individual agents, are growing in knowledge, but they're all sharing it with each other. So then you get this collective intelligence that kind of happens as they're able to share knowledge. And you can't share knowledge if you don't have a common protocol. A protocol is just a language. I mean, unfortunately, I don't speak Swedish, so I'm having to speak English. But luckily, you guys have taken the time, a lot of you, to learn this protocol. So now we've got a common protocol for all the AIs to speak to each other. We haven't had that up until now. And all our AIs are pretty well siloed. So that's the world as we know it right now, 40 billion computers. The great thing about software is you drop it into that thing and it can go at light speed anywhere in the world. We're building training centers initially in a lot of the lesser developed countries. We want to make sure that this stuff doesn't only hit. We're already working in Europe and the US, but we're building training centers in Latin America, Southeast Asia, Africa, in Ghana, Cote d'Ivoire, Nigeria, Kenya, and also in Pakistan and India. So that way the thing starts lighting up kind of all around the world pretty nicely in 24. And we think it's kind of like the App Store. Apple brought out the iPhone, and then a couple of years later they opened the App Store, and then the explosion happened. And same thing with the World Wide Web. They kind of demonstrated a few websites, and then Amazon and everybody jumped in. So these things will work similarly. I mean, we'll release the toolkit probably at the end of the year, and then 24 people will build things. But I think summer of 25 on, I think it explodes and just starts to spread around the world. There's the spatial web protocols. You're happy to join the committee. It's an open committee. IEEE is a standards body, a global standards body. They've deemed the spatial web protocols a, what do they call it there? A social imperative, public imperative protocol, their highest level. They really are concerned as a standards body with the current web. They feel it's pretty broken. It's hacked, a lot of surveillance capitalism on top of it all, and then and then fake news. I mean, what's real, what's fake. And so spatial web with AI can clean up those things pretty rapidly. So you clean up any, give things a truth score. This is looking at 80, 90% positive. This is pretty sketchy. So when you're reading something, you have a truth score on it. And things like blockchains and cybersecurity technologies related to AI help us clean up against hacking and tracking as well. And we also have self-sovereign identity built into the spatial web protocols, if you know what that is. But basically it means that you own your data. You don't log in anywhere. You have agency on the web. So when Tim did the original internet back in 1970, and when Tim did the World Wide Web, he didn't put in an identity layer. Nor a location layer, nor a security layer. So it's just an open web. That's why it's so hacked. So we've cleaned a lot of that up, and you can kind of see it here. So there's your parallel protocols. But in the spatial world, we're stateful. You have agency. You own your data. We'll have data exchanges built into the spatial web, so people can actually sell their data. You can anonymize your data and sell it and get paid for it. Google and Facebook are making a lot of money from your data right now, but in the new web, that money goes directly to you. So if you have a Tesla, as an example, Tesla would love to buy the data from your car. They'd like to see their whole fleet, and they'll buy that data from you. And you can anonymize. It doesn't have to be your name. They just know that somebody living in Sweden is driving a Tesla Model 3, and they want to see when the brakes are going out or how the batteries are holding up or that kind of thing. So they'll buy that data from you. And that'll happen over and over and again as we move through the metaverses, whether we're shopping, whatever we're doing, we're generating a data stream, and you can sell that data. Another look at the stack here. You can see every 15 or 20 years, the whole stack changes. It's interesting. It never changes in one level. All three levels change. So in the 80s, we had email, but mostly we spent time on our Macs and PCs using GUI desktop interface. We used programs like Word and Excel, and we stored our data in a hard drive or a LAN. And that was the world we were living in. We had no idea what was coming. And then in the mid-90s, somebody said, hey, there's this thing called websites. Oh, well, then websites became the new logic, and the browser became the interface. And we had web servers for serving up the websites. What's cool is we don't lose the old one. We keep it, but we spend 80% of our time in the new stack. And so obviously when the smartphone came in, then the logic switched from websites to apps. The data moved to the cloud, and the interface was touch. We still go shopping on Amazon or whatever over here on the web, and we still send email and use Word and Excel. So we don't actually lose the thing, but trust me, 80% of our time, if not more, spent with our smart devices. So you can see what's coming here. This is the next 80% play. Your logic is AIs or IAs. Your data is stored in DLTs and graph databases and other edge technologies, and the interfaces there's a little twist to the interface this time. The human interface is AR/VR. It doesn't mean we can't see it on a browser. We can, but we're going to have headsets. I mean, from Apple just is launching theirs, and we're going to see a flood of headsets from 2025 to 2030. And by 2030, we're going to be using headsets the way we use smartphones. And so the human interface, because we have binocular vision, is three-dimensional. You guys are already working a lot of that here in the visual programs. But there's IoT. What's that doing with the interface? Well, we can't use IoT. We can't see IoT. That's how the AI sees the world. The IoT is the interface for the AI. So the AI is looking through cameras and sensor data and reading the movement of smartphones and cars and things like that around the world. And it's building up its real-time digital twin of the world from that. So you've got two users of this system. You've got here it was only humans. Here you got two users. You got an AI and a human using the exact same system. And so what the AR/VR does is it lets us see what the AI is seeing, and the IoT lets the AI see what we're seeing. Isn't that cool? Amazing. Come on, this is awesome. There's, again, a little example between HTML, which is marking up a page, and HSML, which is marking up a space. And you also have domains as well. So you can control who's allowed to come in here, what are they allowed to do when they're in here, just like a web domain. You have a spatial domain. So if you own a hotel, you own the domain for that hotel. If you own a restaurant, you own the domain for the restaurant. And so the city can have domains broken up, and they're nested domains. Your restaurant might be in a building, so you have your domain for the restaurant. Building has its domain, and then the buildings in the city. Well, then the restaurant can just pay its rent directly, digitally to the building, and the city can pay its taxes directly. The building can pay its taxes directly to the city. And of course, then you've got the state above that, and maybe the EU above that. So if the law is passed up here, it's inherited all the way down. No discrimination laws, other kinds of things that GDPR, these kinds of things. So you have to have nested domains in a spatial environment, whereas in a web environment, they're pretty flat. You can just move between Google, Amazon, Facebook, all of them. But in a visual environment, in a digital twin environment, you have to have nested domains because they're parts of other things. Now, you guys know all about digital twins. I don't have to say too much about that. So you've got your real world thing, and then you've got your digital twin. Again, what we're very interested in is making that a smart twin so that you're reading the data in real time and you get this cybernetic cycle going. And again, same thing, taking data in real time off any physical asset and giving the AI the ability to make micro adjustments that no human would ever think to make, just like it does in our body. Again, a lot of this stuff is a simulation of what's already happening in our body. While I'm having this conversation with you, my autonomic nervous system is actually digesting my food, beating my heart, doing a whole lot of other things. Maybe, I don't know, 50, 60, 70, 80% of my brain is dedicated to actually running this body. But because that's all been automated, I can actually have this conversation. So we think that the AI will function almost a little bit like an autonomic nervous system for us over time. So we can automate more and more of our city services and of our planetary management services, econometric modeling of the climate and carbon credits and how much we charge companies to put carbon into the air and how much we pay people to draw down and all this kind of stuff. AIs can turn that into almost like a carbon game and make it available. So obviously digital twins of places. I know that you guys are working also on digital twins of people, the MRI scans of the human body. And so again, what we've had up until now with the machine tends to treat everybody pretty much the same. But an advanced AI like we're talking about, everything's customized, really just for you. So your particular digital assistant really is really concerned about you and your particular needs and learns about you. And so we're going to see very customized medicine. Even things like clothing. Right now, you kind of go and buy things on a rack, and it's small, medium, large, or in the case of women, it's numbered sizes. But they're not really that accurate. But in the future, you'll just take 10 pictures of yourself, and the AI will calculate up your exact body, and then the the robotic clothing maker will just cut the stuff specifically for you. So it's you're going to see that in education. You want to learn anything from engineering to French, the AI will just figure out exactly where you are right now and then help you evolve your understanding of the field and probably even adapt to your favorite learning style. Some people are more auditory, some people are more visual. And so customization, mass customization. So we think what we would consider PhD level work, probably by 2040, that'll be 12-year-olds. That'll be 12-year-old knowledge by then, you know. Kids will just grow up with VR and AI working together in advanced education environments. Whole cities, of course, cities are responsible for probably 60-70% of our climate problems. And so obviously getting the digital twin of the cities inhabited by good AI, and we start to get a better handle on controlling our climate. And then HSTP, just like HTTP connects all the web pages, HSTP connects all of the IoT devices, all the digital twins, all the intelligent agents. And now you've really got a hologram of the entire planet. There was a famous scientist back in the 1960s and 1970s named Buckminster Fuller. And he said, what we need to do, I don't know how to do it, but what we really want to do is create something called the world game. And we all play it together. And nobody gets left behind. And if we play it right, there's so much abundance that there's no more homeless people, there's no more real poverty anymore. And he wrote a really cool little book called Operating Manual for Spaceship Earth and a couple of other things around these ideas. I think we can get at it now. We've got a shot at creating the world game. And that could be something pretty extraordinary. So that's the spatial web then. It's a network of these digital twins with embedded AI. And that does a lot of stuff there, as you can see. Smart everything, all connected together. And that leads to really the end goal state, which is something like the UN Sustainability Goals. There's 17 of them. Smart planet. You know, right now they articulated the 17 SDGs, but they're not really making much of a dent in them because until you have an integrated system that connects them all, it's hard to do much about them. So once you've got your digital twins all connected, now you've got global collaboration. What they learn in Singapore, you can apply here. What you learn here, they can apply in Cape Town. And so that leads better management of transportation, handling construction and maintenance more effectively, emergency services. I mean, the list goes on. Adaptive health, customized for you. You know, a lot of features and benefits come with it. You know, just it's a remarkable new kind of computing environment that all of us that work with computers have been seeing in science fiction for the last 40, 50 years, whether it's Star Trek or Star Wars or Ready Player One or whatever. But now we got it. We can do it. Step by step, every year we'll improve it. You're going to have these personal agents as well that kind of function on your behalf with this network. So you can interact with it just the way you do Siri or whatever, only it's highly intelligent. And you can make it even look like a person or anything you want. But it ends up being your digital hands. You don't really... right now we watch an old movie and we see people going into a payphone and putting money into a phone and making a call, and it seems kind of humorous, but kids in 10, 20 years will look at us on keyboards and go, what are you doing? You just talk to the computer. Why are you typing? You know. In fact, maybe with Neuralink, we won't even talk. We'll just think, you know. So the GIA then is our generalized intelligent agent. That's your personal assistant. And that'll be acting on your behalf. So you just tell GIA, hey, get me flights to Paris, and it'll do it for you. So we don't think it's a danger. It's not like AI is going to take off and leave us behind. We're going to co-evolve. If you bring anybody here from 1,000 years ago, they look at us, or even 200 or 300 years ago, they look at us going, what kind of humans are you people? I mean, jet planes? I mean, rockets? Robots on Mars? Submarines? I mean, what's going on here? You guys are geniuses. Oh, we are to the people of 2100 and 2200, like those people from 300, 400, 500 years ago are to us. We're going to get way smarter. We're going to co-evolve with the AI. So it isn't, a lot of people have a lot of this fear of this AI growing up and then taking over, and then we're all like enslaved by it. No, we're going to co-evolve with it, and we're building it in these micro environments. So we're actually growing it together. So smart city, smart nation, smart world. You can see some of the issues that we can now get at. We haven't been able to get at. I go to the World Economic Forum and deal with the UN, and we're dealing with the EU, and everybody's just totally frustrated. There's like no advances being made. McKinsey did a study of 300 smart city projects, deemed them all failures. They don't interoperate. They were silent. This was built by this company. This was built by this company. This was built by this company. They don't talk to each other. They don't know what they're doing. My nervous system is completely connected to every cell in my body. When I eat, every cell in my body gets what it needs. It's monitoring my heartbeat is keeping my body at homeostasis right now. If I run up and down the stairs, my heart will beat faster. I don't do that. Well, we've got to do that for the planet. That's the body that we're dealing with here. And of course, it's going to create just massive amounts of new opportunities for entrepreneurs. Just massive. Anybody can make AI agents now, And so there's your SDGs. That's really where we want to get to. A planet that works, a planet that's healthy, a planet that isn't in danger. And there's a lot of work to do to get there, but maybe from 2025 to 2050, that's the journey we're making. So we think in the 2040s, it's, we got a pretty good shot at a decent hologram of the planet that's doing some pretty cool stuff. This is the former vice chairman of Deloitte. He quit Deloitte to become chairman of the board of my company. Carl Friston quit just being a professor at UCL, became chief scientist of the company. So we're drawing in some pretty heavy hitters. So it isn't just me saying this. We got a lot of great people around us, a lot of great people in the company. Like I said, we're about 100 people now, about $50 million on the table. So it's been a very serious undertaking, and it's the life work of a lot of people. I mean, Friston and all the PhDs there, this is what they're totally dedicated to, and all of us on the Silicon Valley side, same thing. So that's a quick look at how we maybe get to a smart world, and how we're not going to do it. We're just going to provide some tools, and you're all going to do it with us. Thank you.